Now, why do we need a unit for measurement? See, first of all, what is a unit? As we just explained, that physical quantity is, if I am writing in terms of numerical value only, so the numerical value will consist of a value into the order of magnitude. Let's consider that whole as a numerical value. So physical quantity is some numerical value times the units. Now what is units and why do we need them? First of all, see, initially trade never happened in the way we are doing it these days. For example, if I want to buy a new pair of shoes, I'll be going to merchant and I'll be paying them money, and in return I'm going to get the shoes. But back in the old days, there we never used to have such sort of currencies and everything. So at that time only barter system was into play. What is barter system? It was exchange of goods in return to whatever you give. So suppose there is a merchant from India and there is a merchant from Nepal. So they used to exchange their goods. So one will bring one trolley of, let's say, coconut. One will bring one trolley of, let's say, cardamoms. So they will exchange their goods and they will come back. So now then they will sell it in their regional parts. So point is, how are we so sure that the amount given by this merchant was equal to the quantity given by this merchant? We aren't. For example, if I want to barter iron with wool. So now you see wool is so light and fluffy, it occupies a lot of space. So even if I give 2 trolley full of wool for return of 1 trolley of iron, my part will not still be compensated, right? Because I am giving 2 less in return of 2 much more. So barter system was, that is why it was not acknowledged anymore throughout the world. They made this society basically, this is International Bureau of Weights and Measurements. This society got established and they defined particular set of unit for all sort of physical quantities that exist throughout the physics. For example, for mass, 1 kg is defined as the standard units for measurement. For length, 1 meter is defined as standard unit of measurement. For time, 1 second is defined as the standard unit. So that what is 1 kg, what is 1 second, what is 1 meter, that is defined and governed and acknowledged by this society. This quantity is made in such a way and this is established in such a way that the quantity will not vary throughout the globe, irrespective of temperature and weather conditions, irrespective of any pressure conditions. So 1 kg in India will be equal to 1 kg in Europe, 1 kg in any Czechoslovakia, or 1 kg in Netherlands. So the 1 kg has to be constant. That is why 1 kg, which is the mass of platinum iridium cylinder kept at International Bureau of Weights and Measurements, is regarded as the standard quantity for 1 kg, and by using that 1 kg is measured everywhere. So now we have a balanced state of measuring physical quantities throughout the globe. So that is why we do need a unit for measurement. Now what is a unit? Unit is the quantity of constant magnitude which is used to measure physical quantities of same nature. For example, if I say that unit of mass is kilogram, that is kg, so if this is a unit, then kg, then any mass, take any so whatsoever mass, it will be calculated in terms of kg. It will be 10 kg, it will be 7 into 10 raised to power 7 kg, it can be anything, but it will be measured in terms of kg. So what kg is doing here? Kg is just getting replicated, it's just getting multiplied. Suppose I have 5 kgs and I have 1 kg. So what's the difference between 5 kgs and 1 kg? The 1 kg got multiplied by 5 times in terms of 5 kg. So that is why a physical quantity is just a numerical value, that is numerical unit times unit. The unit is that physical quantity of constant magnitude, the magnitude of this remains same, which is used to measure quantities of same nature, physical quantities of same nature. For example, I am not going to measure a length in terms of kg, I will be measuring all sort of masses in kg and all sort of distances in meter. I am not going to mix them up. This is what unit is. So now we know why do we need units. So what are different types of units? Let's study about types of units. Okay. So basically we have got only 2 types of units. So number 1, the most important is, I'll tell you the second one first, it is the derived units. So as the name suggests, what are derived units? which can be derived from something else. What something else? Which can be derived from some other fundamental quantities. So that is why the first one is called fundamental units. So fundamental units are those units which cannot be derived from anything else, and they have their constant fixed values, and all the other units of physical quantities whatsoever can be derived from using these fundamental units only, nothing else. So what are fundamental units? Fundamental units, I just given you the definition. So there are 7 different types of fundamental units. 7. What are those? Mass, length, time, current. These are 4 important fundamental units which you are going to learn throughout your syllabus. Another one, fundamental temperature. 1, 2, 3, 4, 5. I have left 2. Which one? Luminous intensity and quantity of matter. So in chemistry you might learn about that as well. So I am not writing derived units right now. I am writing only the fundamental units, which are 7. Mass, length, time, current, temperature, and the last 2 units, quantity of matter. This is quantity of matter and luminous intensity. In luminous intensity you are not going to study very soon until you reach your graduation. Luminous intensity. So what are the fundamental units? These are basic 7 physical factors, physical fundamental units, of which the proper fundamental units are named, which are, for mass we have kilogram, for length we have meters, time, seconds, current, amperes, temperature, Kelvin, quantity of matter, mole, and luminous intensity, candela. So kg, meter, second, ampere, and Kelvin. These 5 will be used very frequently. So let's talk about derived units for a while before I move on to dimensions. What are derived units? For example, I want to define the unit of, let's say, very simple term, speed. Speed is what? Distance covered upon time taken. What is distance here? Length upon time is in this. So if I have to write a unit for speed, I'll be writing it unit of length upon unit of time. So that makes it meter over second. So hence we got the unit of speed as meter per second. If I want to write acceleration, the SI unit of acceleration will be, acceleration is time rate of change of velocity. So velocity is meter per second upon the physical quantity time, that is the value seconds. I'll get meter per second square. If I want to write the SI unit of force, force is mass into acceleration. What is the SI unit? I'm saying SI unit because I'm coming to that point, system of units. So if I want to write the unit of force, force is mass times acceleration. Mass is in kgs and acceleration is in meter per second square. So see, the SI unit of force comes out to be kg meter per second square. So now what we exactly are doing here, we are just using the 7 fundamental quantities to find the value of any derived quantity. So that is why the whole set of units are classified into 2 parts, fundamental and derived. Fundamental are those basic 7 factors which are not dependent on each other, which are basic necessity to find the value of any derived units, and the value doesn't change anywhere. Second part, derived units are those units which can be figured out from using the 7 fundamental units only.